Hey everyone, it's Mrs. Rechiga here again, and I just wanted to make a quick video to kind of show you Khan Academy and maybe work through a few problems with you guys. So here I have Khan Academy up on my screen. I just clicked on the link to Khan Academy and logged in, and I have mine set to just open up to what we call Learner Home. If you don't see that, just click here on Learner Home, and it immediately shows you all your assignments. So I'm going to talk through some of the assignments I think you guys have been having some trouble with. If you notice, some of them actually say, if I hover over it, it says unit test. This one here says quiz. This one here says quiz. I'm going to hold off on those. Those are the ones I want to do last. So again, here it says unit test. Here it says quiz. I think this one also says quiz. I'm going to start with the ones that say just a topic. So this one right here is just a topic. And let's try one or two of them. So here I have a sinusoidal equation. It says select one or more of the expressions that together represents all the solutions. So this is the new stuff we're learning this week. So if you weren't in our office hours, you might want to go back and watch that or just keep going on this video. You can also always click right here at go to lesson page. And even more so, you can, if you're stuck, you can use a hint. It will actually give you step-by-step process, and you can get another hint, get another hint, get another hint. If you just kind of go through one set of 4 problems, getting the hints, that may help you out. But let's go ahead and try this one. I will give you all the hints. So here we have 16 cosine of 8 x minus 2 equals 6. We're trying to isolate this. We're trying to get this portion right here all by itself, so then we can get to the x. So let's go ahead and let's just add 2 to both sides. And divide both sides by 16. Cool. We actually have it isolated now. And now that it's isolated, we're just asking ourselves the question, when does the cosine equal negative 1/2? That's an actual inverse cosine function. When does the cosine equal 1/2? But that is on our unit circle, so we don't have to use a calculator. We can just say, hey, when does the cosine equal 1/2? If I'm thinking about my unit circle, cosine are my x values. So I'm really asking, when is my x value a positive 1/2, meaning this side right here is 1/2. Well, that leads me to this angle right here, which is pi over 3. And this angle right here, which we could think of as negative pi over 3, or we can think of as 5 pi over 3. And if you would put that into a calculator, you would just get that in decimal form. So what we're looking at is this equaling pi over 3, but we can also make a separate solution for 5 pi over 3. You don't have to do this right off the bat, but I'm going to do it right off the bat to show you one way to go about this. So dividing both sides by 8, I end up with pi over 24 and 5 pi over 24. So this is where I have to remind myself that this is just one trip around the circle. And if you notice right here, it says all solutions, all solutions. So I have to think, well, every full rotation, I hit this point again. So I can think of this as plus a full circle. And every full circle, I hit this one again. So this one is also plus a full circle. So those are the solutions we're looking for. We're looking for this pi over 24 plus 2 pi. And we're looking for 5 pi over 24 plus 2 pi. Remembering, though, that if we divided this here by 8, we also need to divide this by 8. So we're not actually looking for 2 pi. We're really just looking for plus pi over 4. Plus pi over 4. So here is one of those solutions right there. And I think that's all. Let's double check. It looks like I missed one. So, here we go. I forgot the negative version. If we called this negative pi over 3, we could have called this one right here also negative pi over 3 because those are coterminal angles, which means this would have just been a negative pi over 24. Always look for those coterminal angles. They could pop up either way, and that would have shown up in the hints. So think about this as either pi over 3 or 5 pi over 3. So don't worry about this kind of first round of trying these exercises being practice. Don't worry about losing it. These exercises you're supposed to try usually more than once. So let's try one more problem like this. Same idea, we want all the solutions to this equation. So 30 cosine of 30x plus 14 equals negative 16. Let's start off the same way. Let's subtract 14 from both sides. Divide both sides by 30. And now we're going to think, well, where does the cosine equal negative 1? That's actually doing the inverse cosine. At what angle is our cosine negative 1? Again, I like to think of my unit circle. My cosine is my x value. Where is my x value negative 1? Well, there's just one lonely position right there at pi. So 30x must be equal to pi. But remember, and I'm going to do this now because hopefully you'll just get in the habit of this, every rotation, we come back. So it's actually pi plus 2 pi times however many rotations we go around. So let's just take one last step and let's solve for x. So we do get pi over 30 plus pi over 15. Or let's look for something that should be similar. So I'm just going to evaluate the other answers. Negative pi would have been correct, but it wouldn't be plus 2 pi. We would want it to be plus pi over 15. And these ones wouldn't necessarily account for that plus pi over 15. This one is doing plus pi over 30, so that one wouldn't work out. So yeah, I think we've got the only one. Cool, so that's solving sinusoidal equations. Again, I could keep working through this, and if I get 3 out of 4 right, then I'm happy with that. Stop, that's 75% for your classwork, for your homework. Or I could try those again and try to get a 4 out of 4. Let's try another one though. So if I'm looking at constructing sinusoidal functions, this is going to be a little bit trickier, so let's try one. So we have the graph of a sinusoidal function intersects its midline at 0, -6, and has a minimum point at 2.59. So I am going to graph that out. So it intersects the midline at 0, -6. So here is the midline of my sine function. And it has a minimum point at 2.5, -9. So we'll say here is our 2.5, here is our -9, here is a minimum point. So I don't know, where the maximum point is, but I think we can figure it out. If I were to fill this in, that's the only piece I know. But I know if this right here is a distance of 2.5, it's another distance of 2.5 to get back to the midline. And it's another distance of 2.5 to get to the maximum, and one final distance of 2.5 to come back to where we started. So this would be right here at 5, this would be here at 7.5, and this last lonely point would be here at 10. So I think I have everything I need now. This is obviously not to scale in the y direction. So let's kind of put this together. I always think of this as y equals a sine bx plus b. Our a value is our amplitude. How far do we go below and above? This one is actually to scale from -6 down to -9. This a value is going to be 3. D is also pretty easy to spot. That is our midline right there. So our D should be -6. And lastly, we want to check out B. If we know what the full period is, it's 10. So B can just be 2 pi divided by 10 or pi over 5. So let's write this whole equation together. Y equals 3 sine pi over 10, 2 pi over 10 or pi over 5, x minus 6. Now let's look back. The only thing that looks off to me, the only thing that looks different, is that my sine curve starts going downward. So it's kind of rotating backwards. To account for that, we're going to make that a -3. -3 sine pi over 5 x minus 6. Okay, hopefully that gave you a little start. I graph these out every single time unless I can kind of intuitively figure out what the amplitude is or if it tells me straight up what the period or midline is. Let's try one more type of problem. Again, I'm just going to go through some exercises with you guys. Let's see. Let's get a good one. So these phase shifts, I've had a lot of questions on. It says consider the following graph using the interactive widget. So it's a sine function. I'm immediately going to highlight this amplitude first. I'm going to extend my amplitude up to 4. And I'm also going to immediately target that midline. I'm going to take my midline up to 2, which, as it should, it looks like it follows order of operations, so I need to extend that amplitude 4 above 2 now. So next, I want to think about factoring this out. Think about what does that look like when I factor this out. So I have pi over 4x plus 3 pi over 4. If I take out the pi over 4 to see really clearly what my period or frequency is, I can see now that my x shift is back 3. Back 3. So I've taken care of the 4 as the amplitude, I've taken care of the 2 as the midline, and I've taken care of that -3 as my starting point. Now to do this guy right here. That is our frequency. That is our frequency. So we can use 2 pi, which is our entire full circle, divided by how many times we see that curve operate, or divided by our frequency. Sorry guys, you can't see that. To find out what the full length or the period of our curve is, which is the same as 2 pi times 4 over pi, 8. So starting here at 3, my entire curve should extend 8 units. My full curve should fit there between 8 units. And it looks like I lost it. So now I just get to figure out how to shift it backward. There we go. Okay. So you guys probably did this way better than me. If this full curve finishes 1, 2, 3, 4, 5, 6, 7, 8 units over, this quarter of the curve is just 2 units over. So there we go. Let's double check. We have an amplitude of 4. From this, it extends up 1, 2, 3, 4, and down 1, 2, 3, 4. Plus 2, our midline is at 2. We have an frequency of pi over 4, so that means a period of 8, from the middle of the curve back to the start of the curve right in the middle, that's 8 units, or you can choose any 2 points, they should be 8 units apart. So here, -1, +7, 8 units apart. And lastly, we've shifted it back 3. Okay, so hopefully that helped you guys get started on some of these. Just going to scan through, see if there are any other ones we might want to check out. Nope, I think we're good. If you guys have questions, please bring them to office hours. I love how some of you guys have just posted a picture of a problem you were kind of wrestling with on Google Classroom. I'll do my best to respond to those as I can, but please respond to each other as well. Thanks, guys. Have fun with Trig.